Hi everyone! Today's video is going to be about the equilibrium, and the goal for today's video is I will be able to compute physical quantities for systems at equilibrium using Newton's laws. In order to do that, we first need to know what equilibrium is. Equilibrium, a system is in equilibrium when all the elements of the system are at rest, which means they're not moving, or they're moving with constant velocity. If this is true, the sum of all the forces on the system should be equal to 0. This is the sigma sign, which means this summation. When we have this type of problems, we want to follow the 6 steps to solving the problems. First, we want to draw a free body diagram to show all the forces acting on the object. Second, we want to write the equation for the net force in x direction in terms of forces. Third, we want to write the equation for F net force in y direction in terms of forces. Next, we want to write an equation for the F net x net force in terms of Newton's second law, then write an equation for the net force in y direction in terms of Newton's second law, and then solve. Let's look at this problem. What is the tension in each string? We have a weight of 80 newtons hanging on the string here, which is then divided into the 2 strings at these 2 angles are given. So I redrew this problem in a different way. I changed the angles. I just recalculated. Now it's 55 degrees relative to the horizontal line and 30 degrees for the second tension, for the second rope. So first we want to do is to draw the free body diagram for hanging mass. So the hanging mass is going to have only 2 forces acting on it, the force of gravity and the tension 3 in the vertical rope. So we're going to follow our steps for solving problems like this. So the net force in y direction is going to be tension minus Fg, and we only have forces in y direction, so we're not going to use the x direction in this case. So, and the second equation for the net force in y direction will be the Newton's second law equation, which is ma, mass times acceleration, and it equals to 0 because acceleration is 0. So we can solve for using these 2 equations, we can solve for T3, and T3 is equal Fg, and here it is equal to 80 newtons. So let's move on to the second, to the other 2 ropes where we have to find the tension force. So we want to draw the free body diagram for junction, junction point right here. We have, let's write the net force in x direction, which is a negative component of T1 force, which is negative T1 times cosine 55 degrees, plus positive component of the T2 force, which is T2 times cosine 30 degrees. Then we are going to write the equation in terms of the Newton's second law, which is F net in y direction is T1 sinus 55 degrees. Oh, sorry. No, this is the, we continue with our 6 steps. So this step is writing the net force in y direction, in vertical direction. So it's T1 sin 55 degrees plus T2 sin 30 degrees and minus T3. So we have a T3 and the 2 components of the T1 and T2 forces in y direction. So the rest is, there are 2 more equations, and we know that there is no acceleration in either x or y directions. So when we're solving all this, we're coming to the system of equations. 2 systems of equation with two unknowns, So the unknowns are T1 and T2. We can solve this system of equations. We can find what T1 is equal to. What T2 is equal to is T1 cosine 55 degrees divided by cosine 30 equals 0.662 times T1. Now we can plug it into the second equation for T2 right here, and then we can solve for T1, where T1 equals to 70 newtons. And then we can go back and solve for the tension in the second rope, which is T2, where we multiply this number by T1. Make sure when you calculate sine and cosine in your calculator is set up to degrees, not to radians. Because if it's set up to radians, you will get a completely different result. And the answer is, for the second rope tension, is 46 Newton. Now let's look at another example. We have an equilibrium problem. So we have a mass M2, which is 10 kilograms, hanging vertically on a rope that is thrown over a pulley, and it continues to the mass M1 on an inclined plane with the 28 degrees incline. What is the mass of this body right here? I redrew this problem. This is mass 2, mass 1, and we need to realize that the tension in this rope here is equal to the tension in this rope right here. So keeping this in mind, we can write the free body diagram, draw a free body diagram for the M2 vertical mass first. We can see there are only two forces acting in vertical direction, and there are no forces acting in horizontal direction. And F net in vertical direction equals tension minus gravitational force, which let us solve for tension, because we know the gravitational force here. At least we can calculate it because we know the M2 mass, 10 kilograms. We multiply by 10 or by 9.8 in this case, meters per second squared, or newtons per kilogram, whatever unit you want to use for G. And 98 newtons is the force of tension in the vertical mass. So we can use this force of tension to find the mass, the unknown M1. Okay, so for the second mass, which is on the inclined plane here, the free body diagram is a little tricky. So you need to get used to this kind of problems by practicing until they start to click. So just be patient with yourself. So here we have a free body diagram with for the M2. M2 is represented by the dot right here. So, and I'm turning my x and y axis 28 degrees to the right. So this angle here is going to be 28 degrees because that's the number of degrees for my inclined plane. Because, why am I doing this? Because I want to have my x and y axis in this direction. So this is going to be my positive x in the direction which is parallel to the inclined plane, and this is going to be my positive y direction, which is perpendicular to the inclined plane. Positive x, positive y. So in this situation, I will have tension only in x direction and normal force only in y direction. So that makes it easier for me to solve, right? So let's see what we have here for the net force in x direction. This is our x direction. So we have tension, which is positive, minus the component of the gravitational force, Fg times sine theta. Why is it sine theta? Because this is our g, which is always down, and this is going to be our component of g, which is horizontal for our system of coordinates. So this is our component, and if this is the angle, it's opposite side from the angle, so it's a sine theta. Okay, so and the second equation, f net in x direction equals to 0. Then we can continue with our equations here. So we can say that there is no acceleration in x direction, so t minus fg sinus theta equals to 0, and it's the same as t minus mg times g, because the gravitational force is mg, remember, sine theta equals to 0. From here we can find out that m1 equals t divided by g sine theta, and we know t from the previous step, remember, and that m1 equals 98 newtons divided by 9.8, which is g meters per second squared, times sine 28 degrees. So the mass is going to be 21 kilograms. Please complete the Google form and answer the question. Thank you for watching.